Assalamualaikum and hello everyone. First of all, welcome to Electromagnetic Field Theory course. In this course, you will learn a total of 11 topics. For today, you will learn about the mathematics preliminary. There are two important topics in mathematics that you need to learn before you able to solve problem related to EMT. The first topic is a vector analysis and the second topic is a coordinate system. Fail to understand these two topics, you will face a problem to solve any problem related to EMT. So make sure that you able to understand these two mathematical principles. In this class, I will explain in brief about what is the vector analysis as well as coordinate systems. As introductions, a quantity can be either a scalar or vector. A scalar is only have magnitude. For example, mass or temperature. While for vector, it has both magnitude and also directions. For example, intensity, speed, as well as gravity. Well, let's say this thing have a magnitude, but it don't have any direction. So this is a scalar unit. Okay. And then another thing, it has a magnitude and also the arrow represent its directions. So the second element is a vectors. The vector can be represented in this form. Okay, for example, this is a Cartesian coordinate. Okay, Cartesian coordinate, we have x, y, and z axis. So the a bar, the bar here represent a vector. That means a is a vector. So the component of a is we have ax in the direction of x. And then we have ay in the direction of y and az in the direction of z. So here ax means the magnitude are along the x-axis, ay the magnitude along y-axis, and ez the magnitude along z-axis. While the x, y, and z here represents the unit vector. Alright, a vector contains a magnitude and also the directions. Okay, if you see the a bar in bracket like this one represents a magnitude of vector A. Or we can simplify into just A. And then we have a canopy here like this. Okay, or we call it a cap here. This is a unit vector of A is equal to the vector A divided by its magnitude. And the unit vector is always equal to 1. That means if we have more than one unit vector in a system, so the total magnitude of the unit vector is equal to 1. Okay, electromagnetic wave, for example, radio wave, optical wave, microwave are vectors unit. Okay, do you know what is electromagnetic wave? Okay, you will learn about electromagnetic wave in chapter 11. Basically, the electromagnetic wave consists of the electrical field. Let's say the electrical field in the form of sinusoidal wave propagate, okay, towards the z-axis. Let's say this one is z-axis. And then this wave, this E field, will isolate, okay, around x-axis. Let's say this is direction of x-axis. Okay, this is E. And then we have magnetic field, okay, which is normally perpendicular with the electrical field. And the direction is in the y directions. And these two E field and H field will exist together and propagate at a certain direction z, for example. So this is an example of the vector components. It has magnitude and it has directions. For the time being, you will learn about the E field first, and then the second part is H field, and the third part is electromagnetic field, where it combines both E field and H field. And the source to produce the field will be different. For example, E field is contributed by the stationary charge, while the magnetic field is contributed by the steady charge, okay, and the electromagnetic field produced by the time varying charge. Okay, time varying charge, time varying current lah. Okay, so for the analysis, okay, we have a three coordinate system. Okay, the first one is Cartesian coordinate, the second one is cylindrical coordinate, and the third one is spherical coordinate. Okay, we take one coordinate system, which is Cartesian coordinates. Okay, let's say vector A at point AX, AY, and AZ is written as A bar equal to, okay, X in direction of AX plus Y in direction of AY plus Z in direction of AZ. So basically the point is anywhere inside the Cartesian coordinate system. Okay, let's say this is a vector A. The vector A. So how can we represent the vector A here? Okay, the vector A, okay, from origin to this point is equal to, basically, this part I rename as a part 1, the vector 1, and the second vector 2. Okay, while for the vector 1, this vector is equal to, okay, vector 3 plus vector 4. Right, so the A here is equal to, basically, vector 3 plus vector 4 plus vector 2. So how to define the vector 3? The vector 3 is equal to AX in the direction of X. Okay. And then we have going in along the Y directions, the vector 4. The vector 4 is equal to, okay, AY in the direction of Y, which is a Y components. So this two combination is vector 1. Y is going up. So this is vector 2. Is equal to AZ in the direction of Z. So this is how we represent the vector A. Next, we will see about the position vectors. Okay, let's say the position vectors, okay, starting from origin, which is 0, 0, 0, into another point P as X, Y, Z on the Cartesian coordinate. So, to write the vector position, we write as a P bar, or we can write as a P bar equal to X in the direction of X plus Y in the direction of Y plus Z in the direction of Z. Next is a distance vector. Okay, distance vector is where the vector is between 2 points. Okay, 2 points means it's not from origins. It's from the point P, the first point here. Let's say the point P is located at XY, S1, Y1, and Z1, and then the point Q located at X2, Y2, and Z2. And then we rename the distance vector as a PQ bar. So, to find what's the vector PQ bar, okay, between P and Q, so you can subtract the destination point, which is a Q, to the initial point P. So Q bar minus P bar. And then we split into each component, X, Y, and Z. For the S component, we have X2 minus X1. Component Y, we have Y2 minus Y1. And component Z, we have Z2 minus Z1. This is Z1. So you know what is the component X, Y, and Z respectively.